Hi everyone, and welcome to our last PAT-Forum for this year. My name is Marilena Pagano, and I'm the Application Manager at Hellma. Today, I would like to welcome you to our webinar with the PAT specialist, Dr. Stefano Radice, on the topic Vibrational Spectroscopy and NIR technology for polymer sorting. Today's expert, Dr. Stefano Radice, Principal Scientist at Syensqo, has extensive expertise in spectroscopy, optics, and photonics, supporting R&D projects in sustainability and strategic initiatives. He holds a master's degree in physics from the University of Milano and a specialist title in polymer science from the Advanced School at the Politecnico di Milano. His career includes leadership in vibrational and optical spectroscopy laboratories, fostering industrial and academic collaborations, and contributing to projects on polymer recycling and circular economy topics. We're glad he found the time to share his experience with us today. Welcome, Stefano.
So thank you, Marilena, and thanks to Hellma for the presentation and the invitation for giving me the opportunity to share some work that we done in the last years in the topic of the polymer sorting. And in particular, an application which is related to one of our special polymer used in the packaging industry, which is PVDC, polyvinylidene chloride. The approach to the solution of the challenges in the sorting of these materials used vibrational spectroscopy and the use of most innovative and updated technologies in the NIR spectroscopy field. In this slide, I also indicated the people who contributed to this study, and they are Domenico Ferrari and Stefano Millefanti from the Syensqo side, my colleagues, and Marco Gregori from the TOMRA side for the industrial sorting experiment. The presentation will have the following agenda: an introduction to Syensqo and the presentation about the sustainability challenges in circular economy, especially for the sorting of certain material, the presentation of the vibrational spectroscopy study we made in Syensqo on standard reference material mainly, and the result of near infrared data, again for standard reference sample and the multi-layers, and finally the use of a suitable industrial sorting equipment to simulate a real sorting of a plastic municipal waste stream and the result obtained. And the end, some comments and considerations. A few words regarding Syensqo, because it's a relatively new company. It was born actually in December 2023, so 1 year, and it is a spin-off from the Solvay Group, which has a long history and tradition in science. Probably most of you know the famous Solvay conferences at the beginning of the 20th centuries. They constituted a reference in the advancing of science and the foundation of modern physics and chemistry. I am part of the material sector, which actually put together the activities of two global business units. One is the specialty polymer, which is focused on the special polymers, and it has a wide portfolio for high performance and high outstanding properties material. And the second one, the composite, is more focused on the advanced composite and adhesive material for aerospace and our technological industries. Regarding circular economy, the concept of circular economy appeared in the European Union more than 20 years ago, exactly in 2002, in the 6th Environment Action Programme, And since then, different strategies and activities have been put in place and delivered. There are many targets and ambitious programs on that. I want just to mention this one, this target, which is to commercialize 10 million tons of recycled plastics by 2025, which is actually today, tomorrow, is very near. And this amount constitutes nearly 40% of all European plastic waste. Regarding the packaging landscape, there are performance and sustainability topics which are nowadays strongly intertwined. Actually, on one hand, safety is for sure of great importance because you have to protect food and pharmaceuticals, for example, making sure that their shared life is maintained during the application. And on the other hand, in the last year, sustainability has introduced multiple new targets. And for sure, one of the most important is the recyclability, then the low carbon footprint, and the recycled content in new materials put in the market. Regarding our material, which is PVDC, regarding the grades we are available, one is the Ixon PVDC, which is mainly developed for co-extrusion application in a multi-layer structure, as shown in the left side of this slide, and whose main application are in the food packaging. The other one is Diaphan PVDC. Actually has been developed for coating application, for example, on substrate like PVC or PET, and its main application are related to pharma one. And now let's focus on the material we studied for these experiments on sorting, and it is part of the first category, so for the food application. And the multi-layer we studied is made up in this way, as shown in this same picture, in which we can see 5 layers of material. Number 1 and 5 are made up of polyethylene. 2 and 4, the intermediate layer, are made by ethylene vinyl acetate copolymer. And the blue one, which is the inner layer, is PVDC, which provide the barrier properties to this multi-layer. Barrier properties means barrier to oxygen and in the same time to water vapor. So the challenge for this study was to detect the presence of this PVDC layer for having a good effect in sorting. Let's go straight to the spectroscopic part. And here is shown the FTIR spectrum of the PVDC material Ixon. It is made by ATR spectroscopy. On the left side, there are the indication of the normal mode that characterize this polymer structure, which regarding the polymer backbone, we have a quite low symmetry situation. The symmetry point group of the system is CS, so very low. And the region of the CH stretching, we can note at least two facts. The first one is that the intensities of the CH stretching is quite low. And the other one that we'll see in more detail later is that we have quite a complex structure and some frequencies in, let me say, in the high frequency region of CH stretching are so quite near to 3000 wave numbers. On the other side, here is an example of a polyethylene material. It is a spectrum very known and simple. even considering the fact that despite its simplicity, it has been a subject of debates during the 70s for the right interpretation of all the feature and the small feature of this spectra, of this infrared spectrum. Here are indicated the normal modes with the main assignment, and the symmetry point group of the polymer chain backbone of the structure of polyethylene is D2H. Here you can observe how the intensity of the CA stretching is, in this case, dominating the whole infrared spectrum. And let's focus our attention exactly on the CA stretching region. Again, we observe that the frequencies that are observed for PVDC polymer in the upper part in blue are higher compared with those of polyethylene. The shift observed in this case is around 60 wave numbers, and moreover, their intensity is low. So all these experimental evidences are actually the effect of chemical physical properties and the structure in which hydrogens are in these two polymeric structures. Higher positive charges are present in VVDC polymer due to the presence of the chlorine atoms in beta positions, which actually give rise to quite a strong inductive effect. Moreover, as a consequence, we also will have a shorter carbon-hydrogen bond and a higher dissociation energy. Let's now have a look to the Raman side of the vibrational spectroscopy. Here, the survey FT Raman spectrum of the PVDC material. Again, we have observed characteristic features due to the presence of the chlorine atom in the backbone, especially related to the low frequency side of the spectrum, in which we observe carbon-chlorine stretching and deformation modes. This is the counterpart for the polyethylene. Again, here are reported the wave numbers of fundamental normal modes, and again, the symmetry species which are related to these bands. Let's have a look again in more detail to the CH stretching, because this will have an effect also on what will be observed in a few minutes in the near infrared region of the spectrum. And here we can see that the spectral shift which is observed to considering the PVDC CH stretching frequencies is around 100 wave numbers. And again, the higher component observed for PVDC is very high, is about 2985 wave numbers, corresponding to one of the antisymmetric stretching vibration. Now, this fact will have an important role in overtones and combination bands that we'll see in a few minutes. And this is a survey near infrared spectrum in a very wide range of electromagnetic region, which go from 900 nanometer till 3,300 nanometers. Let's see in more detail a specific region to understand and see the differences and the typical feature due to the presence of the chlorine atoms in the PVDC polymer. And considering the region from 2,200 nanometer till 2,800 nanometer, we can observe at least two components at 2289 and 2332, which are not present in the polyethylene and EVA-based materials. And considering the frequencies, this can be assigned to a combination band of the CH2 stretching of the fundamental normal modes combined with the H-ring and a deformation fundamental normal mode of carbon-hydrogen. And this is the near-infrared spectral region, which is the most used probably in the near-infrared polymer diagnostic. And we can see here two components at 1190 nanometer and the other one and 1690 nanometers, which again are not present in the polyethylene-based materials. In this case, we may assign these two components respectively to the first overtone of the CH2 stretching fundamental and the second overtone of CH2 stretching fundamental. Again, the fact that we observe at a lower wavelength these components is consistent with the fact that we observe the normal modes of the fundamental CH stretching at higher frequency for PVDC. Let's now have a look about the experiment that we performed with an industrial sorting machine, and the collaboration has been done with TOMRA, which is a Norway company which has international distribution of specific sorting machine with different kind of sensors and sensitivities, and for sure is one of the global player in the industrial sorting setup. This is the equipment that we used for our experiment. Is an auto sort which is equipped with two sensors, one in the near infrared and the other one in the visible, and the material that can be examined with this equipment and the setup used is 0.2 tons per hour for meter of the conveyor belt. And the first thing that we performed was to make a classification step with this equipment, giving the right references for the database. This here, the simple image of the polyethylene, and the pixelated gray image that you see on the upper part of the slide is the result of near multiple analysis combined with the visible spectral data. The important point that we also included for sure our multi-layer structure, so the 5-layer containing one layer of PVDC. In this case, again, the orange image that you see for all the objects that have been included in the data set are the result of near-infrared and visible spectral data. What about the result? We used a sort of plastic mix which would have the duty to simulate a municipal waste plastic waste stream, and we added a known amount of multi-layer sample of our multi-layer materials, and we selected to separate this multi-layer from the rest of the plastic waste. And the selectivity rate that we obtained reached the value of 83%. You can see on the right side of the upper part the multi-layer which has been separated from the rest of the plastic mix. And the 83% of the multi-layer actually has been separated from the plastic mix. Now I would like to show you how it works, which is quite interesting. You can hear also some noise here, which are the air jets, and now I put the audio off. You can see a sort of line, a lighter line half a meter before the finish of the conveyor belt, and this is the region where the near-infrared selector sensor works. And after say a fraction of the second, around 300 to 400 milliseconds, the IR jets that you hear before choose if to send in the upstream or the downstream the object that passes through the sensor line. And concluding this study, I would like to stress the fact that if it's possible to use a suitable classification procedure, the near-infrared spectroscopy is quite powerful for the purpose of plastics sorting and in the selection of different kind of material. It was a challenge to identify a multilayer, and but the presence of the PVDC actually, let me say, gave some clear indication in the vibrational spectra that are there are normal modes that are peculiar in frequencies, especially due to the presence of the chlorine atoms in nearby OCH bond. And these signals, these bands, as a counterpart in the near-infrared region, especially in the combination band for sure and the overtones, which can be used to diagnose the multi-layer sample presence. Another aspect I would like to stress is that considering circular economy, the sorting process could be considered as a first step for a good circular economy and a suitable separation of plastic fluxes, which could be pure as possible, as much more pure as possible. So thank you all for your kind attention, please.
So thank you very much, Stefano, for the awesome talk. Of course, if you want to become a speaker in our PAT-Forum webinar, feel free to contact us. We would be very excited to share your experience in the PAT field. Yeah, and then I would say thank you very much for your participation and have a great Christmas and a good holiday.